Hello guys, welcome back to another section. It's good to have you. In our quest for a suitable environment, we embark on a journey to find a suitable location for renewable energy resources like solar energy, wind energy, and some other suitable analysis. And remember, in the introduction also, we mentioned that we're going to do environmental impact assessment to validate our findings. Okay, just a quick introduction to what we have done so far. We've been able to define some of these parameters that we've been using and the criteria. In the introduction, we've been able to talk about the methods that we'll be using in ArcGIS environment, and we talk about using SATI scale of importance to define important variables in a 10 by 10 matrix. Then we've also been able in another video to download solar irradiation and temperature data from SolarGIS. Now in today's video, we'll be talking on how to download our elevation data, that is digital elevation data, and soil texture data from Google Earth Engine. Okay, now without any further ado, let's dive into the work of today. Please subscribe to this channel if you have not done so, and turn on the notification bell so that you'll always be up to date anytime new video is released. Okay, here we are. You open up your browser. I'll be dropping down in the description of this video Google Earth Engine link for our downloading in today's series. But without wasting much of our time, we go straight to select dataset. Okay, dataset open in a new tab. In my case, you can see if you scroll down, you see all that are available. Okay, it might be confusing for you to be able to lay hold on the particular one for your study. So we are going to click on view all the datasets. Okay, here in all the dataset Earth Engine catalog, we are going to see that there are a lot of data available here, a bunch of data available here. Okay, so in order to be able to get hold of the one we described in the introduction video for elevation and soil texture, we are going to type in as follow: NASA SRTM digital. Alright, okay, we have something here. Yes, this is exactly the data that we described in our introduction that we'll be using for elevation at 30-meter resolution. Okay, alright, all we need now is just to click on this data that is in the map area. Alright, now we have access to the description and the metadata of the data. Alright, you can see the period that the data was captured, the provider, and then most importantly, we are going to be needing this Earth Engine snippet in our downloading. And if you go further, you will need to take a look at some of these tabs, description band, and the rest. Then the description, you tend to know more about the data. You can see what the SRTM stands for. Then that's for the description. The band, here we have just only one band, and the estimated minimum and maximum, that is elevation -10 minimum and 6,500 maximum. Okay, then the resolution and pixels, description, elevation. Alright, this is for JavaScript code. In case you are working in Java environment, this is a sample of how to get access to some of the parameters in this image. Okay, but in our own case, we're going to use Python. Alright, the next thing we need to do now is to open our code editor. Alright, you can open any code of editor of your choice, but in my own case, I'll be using Jupyter Notebook code editor. Alright, now I'm in Jupyter Notebook. We create a new Python file. This case I'm going to name it land elevation and soil texture. Okay, I'm using Python 3. So the next thing, or the first thing we need to do now, is to import the necessary library and give authentication. And we do so by first, let's add a comment and give authentication. Okay, so the library we are going to import is EE. Okay, that is Earth Engine import EE. Okay, now let's add another comment. We are going to trigger the authentication, trigger the authentication flow. Alright, and we do so by calling on the EE library dot authenticate function. We open parentheses and close it. Alright, okay, now we are going to initialize the library. Let's add another note to keep it simple. All right. EA dot initialize. We open parentheses and close it. So now we can click on run. Now that we click on run, it's requesting for authentication. It fire up a new tab in my browser, but in your own case, it might still be the same. So all you need to do is just follow the instruction. You copy the URL, then you paste it in a new browser. Then you are going to follow a series of steps in the new browser to give etail authorization to have access to your Google account. Yes. So the code, you're simply going to copy the code and paste it right in here. Okay. In my case now, I'm going to do that behind the scene. Then I will get back to this page. Now I have my authorization code or verification code handy, and I'm going to paste it right in. Alright, as soon as I paste in the authentication code, I click enter button. Alright, so the message came out successfully saved authorization token. Okay, now that our account has been authorized to be able to download from Google Earth Engine, the next thing we're going to do now, bear in mind we are downloading for elevation first. Remember, let me try and add headings here. Keep it simple. Heading 2 is fine. Let's say land. Alright, so the first thing we're going to do now is to import the data. I'm going to keep a comment, import the data. And what is this data that we're going to import? If you go back to the Earth Engine catalog, you see here we have the Earth Engine snippet. So this is the data that you are going to import, and you're going to copy it just to keep the syntax intact. Okay, then we define a variable for that. In my case, I'm naming it L-Hill. Then we paste it. Now we run. No error message. That's to mean that we've been able to import the data successfully in this environment. Okay, the next thing now is to define the appropriate band. Let's keep it simple. And what is this band in our own case? If you go back here, remember we have it here, elevation. Okay, so this is the band that contains the data that we are interested in. So let's go back to the code editor, and we're going to write this simple syntax to gain access to the band. Okay, we're going to define a variable. Let's say LE band equals to. Now we're going to take the data that is our imported data. Then we're going to do a quick SQL syntax. Select. Then we open the parentheses. We're going to include a single quote, and within a single quote we define the name of our band, which is elevation in this case. Okay, we just click on run. Now all is good, no error message. Okay, so the next thing is to define the boundary, because this data contains the entire word elevation. So we are going to narrow our downloading down to our study area, our region of interest. So I'm going to type in few lines of code, and I will explain to you line by line. Okay, now I had a comment here, define the location of interest. In our case is Southwest Nigeria, so we are interested in getting the elevation for the entire Southwest of Nigeria, because that's where our study area is going to cover. Now we define the latitude and the longitude in the geodetic format. That's what this stands for. Then our point of interest now is we're going to fetch from the etail library the geometry of this point, which is going to be, we define the variable ee.geometry.point. Take note of the case, because this syntax is case sensitive. Okay, then we keep in between the parentheses the latitude and the longitude. Now we define the region of interest. In this case, from this point of longitude and latitude, we want a buffering zone to extend for a 250 kilometer radius. Okay, so that's what we have here, region of interest. We call on this geometry we define here, then we buffer it to 250 kilometer. So we're gonna hit run now. Okay, no error message. Now the next step is to begin the downloading. All right, in the same way, I'm going to type in few lines of code, then I will explain to you line by line. All right, Okay guys, I have here downloading, and in this line we are importing image from IPython. So if you don't have this library, just try and download them so you can follow along. So from IPython we're going to call on display, then we import image. Now we are defining the variable for our image, downloading now, which is land elevation download. We call on the EE libraries, we call the batch export image to where are we exporting the image to? We are exporting it to drive, which means the image is going to save in our Google Drive, because remember we've already given authorization for these two platforms to communicate, that is Earth Engine to communicate with our Google account. Okay, so now we are going to save it in our Google Drive, then we are going to export or download in our C drive or external device. Okay, so now we define few parameters for the data that we want to download. We open a bracket, then we define the image. Remember, the data has been presented in form of image, and we've been able to import the image here. So we call on the band, that is image equals the band, then description. This could be anything of your choice, keep it within the single quote. The scale, we're looking at 30 in our case. Then we are looking at the pieces, the maximum pieces, which is this. On the region, this region of interest now refers to the one that we define there, which is 250 kilometer buffering from the point of interest we defined here. Okay, so the file name preface is going to be land elevation in this case, and the coordinate reference system is going to be geodetic, which is EPS6. Then the format will be geotiff. All right, we click on run. No error message, that's to say all is good, but now we don't know what is going on behind the scene. Just with a single line of code as well, we can get the status of the downloading to know if it's running or not. Okay, we do that by calling on the status function. Okay, the dot status. So we hit run. Now we have this message, the state is running. As soon as it's complete, this running is going to change to completed, as you can see other attribute. Okay, as the downloading is ongoing, let's go and get the data description for the soil texture. All right, okay, and we do so by going back to this page where we have the view all data set. Then we're going to click on the view all data set now to take us back to the previous page that we have view all data set. Okay, and for the soil texture now, the same way we browse from the list of data sets, the specific elevation we are interested in has been described in our introduction to this series of tutorial. The same way we are going to type in the text for the soil texture. Okay, now type along, open land map, no space. Okay, land map soil texture. Now we have it here. This is what we are interested in, the soil texture, as you can see. So we click to review the metadata as well. You can see the data set availability, that is from 1950 to 2018. So the compounded soil texture data capture between this period. Okay, you can see the data set provider, and now just like we have in elevation data, you can see the data be presented in this format. So in this case, we're going to copy this to use in the Python code. All right, so if you go down, you see the description. It's a test social class USDA system that is in C soil depth. The data has been presented in C different depth, from 0, which is the surface of the earth, 10 cm, 30 to 200 cm in that order. But in our own case now, we'll be interested in getting the data for 200 cm. Okay, so when you click on the band, you will see the resolution 250, the bands, just like we mentioned. So we are interested in 200. Okay, so if you go further, you will see the description and the value, which is from 1 to 12, and the color code in this order. So this one for band 0 now, that is table class. Then if you go down to where we have band 200, okay, so you see the value range from 1 to 12 and the color code, then the description, the kind of soil, not the type of soil, as the clay soil, loamy soil, sandy soil, and all of that. Okay, so we are going to copy this snippet, go back to our text editor. Now you see we have this running. Let's try it now to know if the download is complete or not. You go back to where you have the status and we run. Perfect. You can see now it's completed. All right, so the elevation has been saved in our Google Drive. We are going to fetch it from the Google Drive and download on an external device or C drive. Okay, so now let's try and add heading for this to keep it simple, separate our elevation data and the soil data. So let's say soil texture downloading. All right, and this process follow the same as we have it for the previous downloading, which is elevation downloading. All right, the same as we gave authentication in ETNG, but since we already have it here, in the case of we having a different file, for every new file we need to authenticate. So to avoid giving several authentication, we just keep it simple, do the downloading for the soil texture here as well. Then we are going to start right as we have it here, import the data. Now remember, we've copied the data, so let's just say import soil texture data. All right, let's say st. Now we've imported the data. Okay, so we run it. Okay, no error message, that's good. The next thing now is to define the band, just like we did for the other one, which is elevation. So we are going to define the band. Remember, we said we are going to be using the 200 cm depth. So let's say st, then b200, okay, equals to, we call on the data st select open bracket single quote, then we keep in the band as it is on the Earth engine b200. Okay, we run this. Now the next step is to define the boundary. Remember, we already defined the boundary, which is going to be South West Nigeria, so we are still going to be using the same boundary that we define here. All right, so the next thing is to start the downloading. Let's copy this line and fine tune it. Okay, so now the same way we are going to import image from IPython, the batch. So we're going to change this band now to stb200. Okay, and for the description is going to be soil. All right, all other things remain. Then for the file name, we're going to write it as a soil texture. This remain, and to avoid confliction, let's try and give this variable different name from the other one, st, then this one will be st as well. Okay, now we can run it to initiate the downloading. All right, no error message. The downloading has started. So let's check the status as well. Alright, the downloading is running. As soon as it's completed, we are going to go right into our Google Drive to fetch the data. Alright, in my Google Drive, okay, to gain access to your Google Drive, you just click on this icon, Google Apps, then you try and locate Drive. Okay, and click on Drive, it brings it to your Google Drive environment. Okay, now for today, these are the data that we downloaded. So we have the airline elevation and the soil texture. So if you go to this three dots, you can see download. Okay, just click on download and the data is going to download. Okay, and now this is the error message is telling you that the data file is large and could not verify it from the virus. You just continue anyway. Why you continue? Just simply because you were the one that keep the data there, so you're sure of where you got it from. All right, okay, so you download anyway. It's going to save right in your device. That's it. So that brings us to the end of this section. The next section, we are going to be downloading our land use data for defining the build up area, and the same way we're going to be downloading power grid data. So see you in the next video. Cheers.